Hello friends. Now in this lecture we will learn some Boolean theorems which are important and necessary to learn to minimize a given Boolean expression. Okay. Very first Boolean theorem is related to a NOT gate. So we will start with NOT gate Boolean theorems first. Okay. NOT logic. In NOT logic, you know that if we take the NOT of 0, we will get a 1, and if we take the NOT of 1, we will get the 0 output. This gives us that if we take 2 times NOT of 0, then we will get the same result 0, and if we take 2 times NOT of 1, we will get this one. This results in a simple theorem that is, if we take a double times NOT or double times bar, then it will gives us a itself. Okay. Now second is OR logic related. For OR logic, you know that 0 plus 0 results in a 0. 0 plus 1 results in a 1. 1 plus 0 will also result in 1, and 1 plus 1 will result in a 1. Now if we replace this 0 or this 1, you can see that here this bit is different. Sorry, if we see these two combinations, for these two combinations there is 0 0 here, that is 0 plus 0 or 1 plus 0. So collectively we see that if we represent this variable with a, then we result in a theorem that is, if a plus 0 is there, then output will be a, because see here the output is same as this. Similarly for this combination, okay, for this combination if a plus 1 is there, then output will be 1. So the theorems are a plus 0 is equals to a, and a plus 1 is equals to 1. Okay. Now let's see the AND related theorems. In case of AND gate, 0 dot 0 is equals to 0. 0 dot 1 is also equals to 0. Okay. So 1 dot 0 is equals to 0 and 1 dot 1 is equals to 1. So this gives another conclusion. If we add a 0 with a variable a, then it results 0, and if we add a 1 with the number with a variable a, then results in a. Okay, see the difference here, that if we or a variable a with 0, then it results in a. Okay, whereas in this case when we AND a variable a with 0, then it results in 0. Okay, that is 0 multiplied with any other variable will results in a 0. So the theorem is a dot 0 is equals to 0 and a dot 1 is equals to 1. Okay, so these are numbered as 3. Now two more theorems results in this case. Here from OR gate, if we OR a with its inverted value, then it always results in a1. Okay, so the third theorem for OR logic is a plus a bar is equals to 1. See here how it happens. If a is equals to 0, then a bar must be 1. Okay, so the output will be 1. Secondly, if a is 1, then output will a bar will be 0, that is 1 0, then output will be 1. Okay, similarly we can have the third AND logic related Boolean theorem, that is when we AND a and its inverted value, then it will result in a 0, because if a is equals to 1, then a bar is equals to 0. This will gives you 1.0 is equals to 0. Similarly, if a is equals to 0, then a bar is equals to 1. This will gives you 0.1 is equals to 0. Okay. Now let us see the associative law. Associative law. Associative law contains two theorems. First one is that if we AND three variables like this, then this is same as a b with bracket with c. Okay, and second is that is if we OR three variables with 2 in bracket, then we can also write it like this: a plus b braces plus c. Okay, now let's see the commutative property. Or commutative law. Commutative law says that if we AND a with b, then it is equal to b and a. And the second is if we OR a plus b, then it will be equal to b plus a. Okay. Next law is your distributive law. Distributive law says that if there is an expression a and b plus c, then we can open this braces like this: ab plus ac. Is that if a plus AB is there, then it can be written like this, that is it is equals to A. Okay, because when we take A as common, then it becomes 1 plus B, and this results in A dot 1, this results in A. And the second is, if A is multiplied with A plus B, then this also results in A, because if we solve this expression, then this results in A dot A plus AB, and this is nothing but A plus AB, and this results in the same value, that is A. Now the important theorem, that is De Morgan's theorem. Or De Morgan's law oblique De Morgan's theorem. De Morgan's theorem says that if there is an expression of NAND gate, okay, like this, then this will be equal to, by replacing your AND operations with OR operations and taking the individual bars like this, A bar plus B bar plus C bar plus D bar and so on. And the second theorem is, if we have a NOR operation, then this can be written like this, A bar dot B bar dot C bar dot D bar and so on. For example, if y is equal to A dot B dot C bar is there, then when we apply De Morgan's theorem, then we can write here A bar plus B bar plus C bar, and this will be equal. Okay, we can easily prove these two theorems. Now before proceeding the proof, let's take another example, that is when we do A plus B plus C whole bar, then this can be written like this, A bar dot B dot C bar. Okay, if we want to see the proof, then here is the proof. Suppose two inputs are there. Okay, A and B. Okay, for two inputs, the combinations are 0 0, 0 1, 1 0 and 1 1. Now what will be the value of A bar? A bar will be equal to 1 1 0 0. Similarly, what will be the value of B bar? Okay, the B bar will be equal to 1 0 1 0. And what will be the value of A dot B bar? That is 1, 1, 1 and 0. Similarly, the value of a plus b bar will be equal to 1, 0, 0, 0. And if we write a bar dot b bar and a bar plus b bar, then the values will be a bar dot b bar, that is 1, 0, 0, 0. It means these two are equal. Okay. Similarly, if we or a bar b bar, then this will be 1, 1, 1 and 0. In this way, you can see here these two results are equal. This implies that a plus b whole bar will be equal to a bar dot b bar, and second, a dot whole bar will be equal to a bar plus b bar, and this is nothing but this is De Morgan's theorem. Okay. See another important law, that is, if a is OR with a bar b, then it results in a plus b. This is very important, please note it. Now let us do its proof. We can represent this a as a plus ab, and if we insert a 0 bit at this position, then it looks like this, a bar b. So this can also be written like a dot a plus ab, and 0 can be replaced by a dot a bar plus a bar b. Okay, take a as common, a plus b, take a bar as common, a plus b, and this results in a plus a bar multiply a plus b, where a plus a bar is equals to 1, a plus b, and hence we get the final result, that is a plus b.